Okay, now having gone through the characteristics of which discrete random variable is a binomial distribution, let us properly go through the definition and some formulas regarding the binomial distribution. Okay, so if x is a discrete random variable, okay, if x is a discrete random variable, whereby we look at the number of successes and there are total of n trials, and the probability of a success is given by p. Okay, then we say that x follows a binomial distribution. Okay, and the binomial distribution has two parameters. Okay, parameters. Okay, the parameters are the number of independent trials and the probability of a success. Okay, so we will also say that, okay, x follows binomial np. Okay, so when you communicate with your teachers, we can just say x follows binomial np. Okay, or x follows a binomial distribution, and these number of trials and the probability of success are the parameters of the binomial distribution. Okay, the formula or the probability distribution function of x is, okay, as such, n choose x, probability of to the power of x, the probability of success to the power of x, probability of failure to the power of n minus x. That's why you notice the formula. Okay, notice the formula here is largely dependent on n and p. Okay, so x is kind of the probability that this thing occurs is much determined by n, the number of trials, and the probability of success. Here also 1 minus p. That's why the binomial distribution has two parameters. Okay, when we talk about a discrete random variable, we always want to know what will be the expectation and the variance of the discrete random variable. So in this case, the binomial distribution has an expectation of n times p, and the variance is a product of n, the number of trials, p, the probability of success, and 1 minus p, the probability of the failure. So note that, okay, the probability distribution function, the expectation, and the variance, they are all available in the MF26. We will also say, okay, let us look at one simple example. So how do we, the example will help us illustrate how we present our solutions. Okay, so x is the number of sixes obtained from throwing a fair die 7 times. Okay, whenever we are given the questions in statistics, okay, and you suspect that the in this case this random variable follows a binomial distribution, right? You need to go through in your head, hey, whether does it fulfill the conditions of a binomial distribution. Okay, so here there are total of 7 trials. Okay, there are total of 7 trials. Okay, each trial you either get a 6 or not a 6. Okay, and think about it, for each trial the probability of getting a 6 is also the same, 1 over 6, because well, the die is fair. Okay, so based on this situation, because it fits all the 3 conditions for binomial distribution, we say that x follows binomial 7, okay, and 1 over 6. Okay, so part 1. Part 1 requires us to find the probability that x is 3. Okay, x is 3. So over here we apply the formula from the probability distribution function of binomial distribution. It will be 7 choose 3, okay, 1 over 6 to the power of 3, okay, the success, and the failure, which is not a 6, 5 over 6 to the power of 4. Okay, and if you use the calculator to press, this should be 0.0781. Okay, now in part 2, okay, we are looking at probability at most 3, 6. So at most 3, 6 means at most 3, right? So means 3 or less. Okay, 3 or less. So this is probability x equals to 0 plus probability x equals to 1, okay, plus probability x equals to 2, and probability x equals to 3. Okay, so probability x equals 0, 7 choose 0. Okay, no successes, 1 over 6 to the power of 0, 5 over 6 to the power of 7. Okay, plus probability x equals to 1, 7 choose 1, 1 over 6 to the power of 1, 5 over 6 to the power of 6. Okay, and so on and so forth. And the last one would be 7 choose 3, okay, 1 over 6 to the power of 3, 5 over 6 to the power of 4, okay, which we found earlier on, okay, and then use your calculator and press the answers yourself correct to 3 significant figures. Now you may be wondering, the calculator allows us to key in these values to get this value, okay, and obviously this thing is pretty tedious, okay. Is there a shorter cut to handle both questions? Answer is yes. Okay, so let me share with you how you can use the calculator to help you derive a answer in a faster way. Okay, so look at part 1. Okay, now as you are discussing or as you are reading through the questions or what, please take out your graphing calculator. So how do we key in binomial distribution? Okay, where number of trials is 7 and the probability of success is 1 over 6. Okay, so in your calculator you press second, okay, and VARS. Okay, so we are looking at the distribution here. Okay, we're looking at the distribution here. Okay, so press second followed by VARS. Okay, you will see this screen appearing. Okay, you will see this screen appearing. So over this screen, you will press the down button or up button, okay, until you select, okay, you select A, binomial PDF, binomial PDF. So when you press enter, trials would be the number of trials, and P will be the probability of success, X is what you want to find. So over here, we are looking at X equals to 3, so you press 3. After which, I think here is a paste, there's a word paste, okay, you enter paste, okay, you enter paste, and you should see, you will go back to the normal screen and you should get 0.0781. Okay. Now, if I'm looking at part 2, at most 3 sixes. Now imagine if I don't have the graphing calculator, I have to press all these, which can be very, very tedious. So can we use how can we use our calculators, graphing calculators, to help us get the answer faster? Okay, so likewise, just now, right, we did PDF. Okay, we did PDF to find probability X equals 2. Okay, so I shouldn't be using this. Okay, we should be using sorry, as I was saying, over here, this should be binomial PDF, right? We want to find probability X equals to something. So if we want probability X less than or equals to something, we use the binomial CDF. If you remember in the earliest topic, we talked about the cumulative distribution function. Okay, we talked about cumulative. So the CDF here represents cumulative. Okay, so over here we select the binomial CDF. Okay, number of trials 7. Probability is 1 over 6, trials is 3. So when we put this in the binomial CDF, we are tabulating this value. Okay, we are tabulating this value, and you press equal, you will get this answer instantaneously. Now be very careful that suppose the question wants us to find, okay, probability X less than 5. Okay, now probability X less than 5, if you want to do a binomial CDF, okay, is actually equivalent to probability X less than or equals to 4. Okay, because if the question asks for less than 5 sixes, okay, less than 5 sixes will imply 4 or less. So you must be careful with the use of how the inequality was set up in the question. Okay, now next part, okay, to answer this question, okay, what is the expected number of sixes that are obtained in the 7 throws? Because X follows a binomial 7, 1 over 6. We are looking at expected number of the sixes that appear. So we are looking at expectation of X, which is 7 times 1 over 6. 7 times 1 over 6. So yeah, it is 7 over 6. Okay, and for variance of X, if the question asks you to find, okay, the variance of X would be 7 times 1 over 6 times 5 over 6. Okay, so 35 over 36. Okay, lastly, now we want to find the most probable value of X. Now, most probable value of X actually refers to the mode of X. Okay, refers to the mode of x. So how do we find the mode of x? That means what is the actual number from, because total 7, because x follows binomial from 7, 1 over 6. So the outcomes of x would be, 0, 1, 2, and so on until 7. So which number give us the highest probability? And that is called the mode of x, or most probable value of x. So what we do is, in your calculator, okay, you go to the graph function, okay, y equals to, okay, you go to y equals to, okay. Now, what you can do is, you will key in the function that we have done earlier on. So binomial 7, 1 over 6. But in this case, we don't write a number, we write x. Okay, you write x, you key in over here. Okay, you key in, you paste, you should get this result. After that, now instead of pressing graph, you will press second graph. Okay, press second and graph. Now this screen will appear. Okay, this screen will appear. Now when this screen appear, okay, you notice that the probabilities that will occur will be 0 to 7, as mentioned, right? Because these are the 8 possible outcomes. So you will pick to find the most probable value of x, you will choose the x that gives you the highest probability. So the one with the highest probability should be this. Okay, for x equals to what? 0.3907. So to answer the question, the most probable value of x, okay, value of x is 1. Okay, now in a binomial model, right, the mode usually is close to the expectation of x. Okay, the mode is usually close to the expectation of x. So earlier on, the expectation of x was 7 over 6. So the mode being 1 is pretty close to 7 over 6. Okay, so this is how we can also guess what the mode of x is. Okay, but using a calculator is a better way to, instead of guessing, is to get the answer.